So 3.5 factoring by grouping. This method only works on very specific types of polynomials. So you can kind of trust that most of what we're going to do today, it's designed for it to work. However, if you just pick a random set of numbers for your polynomial, there's a good chance that it won't work. Okay, this only works on certain ones. We've picked the ones that it does work on. It helps us factor things that we couldn't otherwise factor. The lesson from either Thursday, for you guys, Wednesday or Friday, we'll learn one more tool to factor things even beyond just this. But again, I know we're all coming back for lunch. Make sure your masks are all the way up and let's get started. So for number one, x squared times x minus 3 minus 4 times x minus 3. Do you all see that they have something in common, that there's something repeated there? The goal here is to notice that, oh, these both have a x minus 3. Does that make sense to everybody? So just like with any other GCF, I can factor something out that they have in common, even if it's a whole set of parentheses, okay? Both of these have an x minus 3, so I'm going to factor that out and say x minus 3 here was multiplied by an x squared and by a negative 4. Does everybody see what I just did? I took that x minus 3 and wrote it one time out in front. Even though I had 2, I wrote it one time to say this x minus 3 is multiplied both by x squared and by negative 4. If I distributed this all the way out, it would be x times x squared, x times negative 4, negative 3 times x squared, negative 3 times negative 4, which would be the same thing as doing x squared times x squared times negative 3, negative 4 times x, negative 4 times negative 3. If I multiplied it back out, I would get the exact same thing. But we don't want to do that. We want to get the factored form. This is more factored than originally, but can I factor it even more? What do we see that factors more? X squared minus 4 is a difference of squares. Does that make sense? Once again, we're going to get a ton of these. So that x squared minus 4 is going to factor one more time into x minus 2 and x plus 2. And then that x minus 3 is going to stay in front. And we are done. Does that make sense? That's it. That's all we're learning today. Now, this starts us off partway through. They did the first step for us. So I'm going to have to show you how to do the first step. But literally what we just did right there is today's lesson. So the next one, do we all see r plus 2, r plus 2, r plus 2? The same thing happening 1, 2, 3 times. So what I'm going to say is, okay, r plus 2 is multiplied by a and negative b and c. So notice how everything that was multiplied by r plus 2 goes in that parentheses, a minus b plus c. Does that make sense? And again, if I distribute it out, it's a times r, a times 2, negative b times r, negative b times 2, c times r, c times 2. The same thing I would have gotten if I had just done the distributive property at the beginning. So again, done there. We hit number 3 though, and we have a little bit of a speed bump. Something's wrong with this problem. Do you see how this set of parentheses and this set of parentheses are not exactly the same? In order to do what I was doing before, they have to be exactly the same. In this case, they're close. The difference is the signs are all switched, right? I've got a positive 2a and then a negative 2a. I've got a negative d and a positive d, and then order switched. There is a very simple, easy trick to make these match. And it's going to come up 1 out of every 4 problems. It's going to come up pretty frequently, but not all the time. If the 2 sets of parentheses are exactly the same, but the signs are all switched, you can take a negative out, essentially factor a negative out of all the terms. So I'm looking at this one, d minus 2a. I can take a negative out there. The opposite of D would be negative D. The opposite of 2a would be positive 2a. So I took that negative out, and then I have to put it somewhere. I'm going to put it on the outside with that negative x that was already multiplied by it. So what's a negative times a negative x? A positive x. So all I did was take the negative out of this and put it in front of that. It switches all my signs. Now when I look at this again, I'm sorry, I made that a little bit squished there. Now the 2a minus d matches in both. Does that make sense to everybody? I know that one got all squashed right there, but everybody's good. 2a minus d, 2a minus d, exactly the same. So now I can factor that out. Put that 2a minus d on the outside. And then left over, that was multiplied by a 4 and by a positive x. There is my answer. That one's done. So that was the one extra trick there, was that you can take a negative out of a set of parentheses if the signs are all opposite. Now, if only one of the signs is wrong, you're stuck. You can't fix that. But if all the signs are backwards or opposite, take that negative out and just put it on the front. So that was all lead up. Here's the real deal, the full thing. Number 4. For number 4, there are no sets of parentheses yet. But if the problem is designed to be factored by factoring by grouping, or if factoring by grouping is going to work, I can essentially take the first two and say, okay, what do they have in common? Can I do a GCF with those first two terms? X squared, right? Does everybody see that? They both have x's in them. Specifically, I can take an x squared out, and I'll be left with an x plus 3. The next one, negative 4x minus 12. What do they have in common? Okay, check again. Negative what? Right, negative 4. Does that make sense to everybody? Take a negative 4 out of both of those, leaving me with x plus 3. If I did this right, and if it's designed to be factored by factoring by grouping, those two parentheses should match. If they do not match, either I made a mistake, I didn't factor out the real GCF, the biggest, the greatest common factor, or it's not going to factor by factoring by grouping. Does that make sense? There's plenty out there that don't factor by grouping. Here though, this one did. X plus 3, exactly the same. Factor that out. This guy comes out. And then we say, okay, what were those both multiplied by? The first one was an x squared times x plus 3. And the second one was a negative 4 times x plus 3. Am I done? Some of you are starting to figure this out, right? Differences of squares all over the place. We're just going to keep ending up with them. Here's another one. Factor it one more time. I'm still getting a couple people that are doing x minus 4, x plus 4. Remember, the x squared is x times x. The 4 is 2 squared, 2 times 2. So this is going to factor into x minus 2 and x plus 2. Right there. Does that make sense to everybody? So that one's done. This is what we're learning today. If you've got that, you've got today's lesson. Okay. Everything else is just some more examples, making sure it makes sense, and then applying it to graphing, like what we've done in the past. So let's do another one. Number 5. 5x minus 15, x cubed minus 3x squared. Do these two have something in common? Yeah. Take that 5 out. 5 times x minus 3. Look at the next set. What do those have in common? X squared. So plus x squared times leftovers, x minus 3. Is everybody getting the idea? Greatest common factor from the first two, greatest common factor from the second two. If it works, the leftover parentheses will match. So do they here? Do we have the exact same parentheses? Okay, so we're good. We can factor out that x minus 3 from both. X minus 3 here, x minus 3 here. And then again, whatever's left over, we had a 5 times the x minus 3. And we had an x squared times the x minus 3. Now, that 5 plus x squared, does that factor? No, it's not a difference of squares, right? I could get answers from it, but it's not going to factor. Next one, they're throwing extra letters, different variables in here, but the way you work it is exactly the same. Take the first two, decide what they have in common. Just shout it out, guys. What do those two have in common? Take that y out. We're left with an x plus 2. Next set. Right here. What do they have in common? 3. And you guys don't sound very enthusiastic about it, but you got the right answer, so that's fine. As long as it's making sense. I know it's not super exciting, but it's giving us another tool for factoring, okay? So there, 2 sets of parentheses, exactly the same, factor it out. X plus 2, x plus 2. Left with y plus 3. Does that make sense? No. So again, the idea is the red part right here came from these two terms. I looked at both of those and said, what do they have in common? If this is going to work, they have to have something in common. Now, actually, you can just take out a 1 if you need to. We might see that happen once or twice on the homework, but typically it's a GCF. These both have a y. I take that out. I'm left with x plus 2 because y times x makes xy. Y times 2 makes 2y. Does that make sense? Okay. Eli, you were looking a little worried. Like, are we okay with that stuff?
I'm just curious. So go back to the top one. So 3x plus 6. So the 3 shares with it. You do what? 6 minus 3? Because since the 3 is similar, what I'm saying, the 3x.
Right here?
Yeah.
You're going from here to here.
Yeah.
So the idea is that blue part right there, the 3x plus 6, both of those are divisible by 3. Does that part make sense? So what I do is I take that 3 out in front and say 3 times x plus 2 is the same thing. 3 times x is 3x. 3 times 2 is 6. Like if I did the distributive property. Does that make sense? Okay. So again, you guys, if you're wanting to check this, you can work backwards and do the distributive property for these. And it should, again, give you back the same thing we started with. Even if I did that down here, notice if I do y times x and y times 2 right there, that's the same thing I'd get here, y times x, y times 2. And y times x is xy, y times 2 is 2y. I'm getting back the same thing I started with. Same thing with the blue 3. 3 times x, 3 times 2 is the same thing as right here, 3 times x, 3 times 2. And 3 times x is 3x. 3 times 2 is 6. Does that make sense? So I've rewritten it, factored, but notice how it's not using a form of factoring that we've done so far. The tools that we had originally could not have factored that original 4-part polynomial. Does that make sense? All right, let's do another one. So down here, number 7. I am going to make a mistake, and then I'm going to point something else out to you as well. So right here, 5ab minus 10a. What do those have in common? 5a. So this is not the mistake. So far, you can write this down. This is all good. 5a, b minus 2. Is everybody good there? Here's the mistake. What if I look at the next one and I say, well, I'm going to take out a 5b. That sounds kind of like what we just did. I'm going to take out a 5b. If I take out a 5b plus 5b, 3b minus 6. Do those parentheses match? No, they don't. Why not? What did I make a mistake doing? I didn't factor out a big enough greatest common factor. Does that make sense? What should I have factored out? 15. So let's back up. Make this a 15b. That's going to leave me with b minus 2. Now they match. If they don't match, I can't do factoring by grouping. So now I can take out b minus 2 and b minus 2. B minus 2 goes on the outside. 5a plus 15b on this one. Am I done? What is left? What can I still factor? Michael?
5.
A 5. Does everybody see that? From this second set, these both have 5s. So I can take that out. And so right here, I'm going to take that 5, put it on the very front, be left with a plus 3b. And then I still have that b minus 2. Now, why did that happen? Anybody have an idea why we ended up with that extra 5 there? Look at the original one, the very first polynomial that we started with before we did any work. Is there a greatest common factor from all 4 terms? Yeah. So I could have taken that 5 out at the very beginning, and I would have gotten the same answer. Does that make sense? You don't have to, though. We just saw, as long as you're careful at the end, you double check, oh, there's that 5, I can take that out of that factor. You'll get the same answer either way. It might have been easier if we took that 5 out at the beginning, but it's not necessary. All right, this next one, we're going to have a slight issue with again. Just a little one. 12 minus 4x minus 3x squared plus x cubed. First 2 terms, what do they have in common? 4. Let's take that out. So right there, 4 times 3 minus x. What do the next 2 have in common? X squared. So plus x squared, negative 3 plus x. Do they match? Not quite. They're so close. What's wrong? The signs are switched. And remember, we learned something with just back in example 3. We found a way to make that switch happen. So I could factor out the negative here, make this a positive 3, negative x, and this a negative. Okay, so I could have made this negative x squared, x minus, nope, positive 3 minus x. Right, take that negative out from inside the parentheses and put it out in front. Now there's another way of doing that. I could have at the beginning just factor out a negative x squared. Does that make sense to everybody? I could have just factored that negative x squared out at the beginning. And often if you're paying attention and watching, you'll see that to know, oh, I need that 3 to be positive. Let's factor out a negative x squared so that the 3 that's left over is positive. Does that make sense? Okay, so we're good so far. 4 times 3, that is a horrible parenthesis. Let's try that again. 3 minus x. We've got 3 minus x from both of those. We can bring that out. I'll try to stick with my convention of using a different color there. 3 minus x, 3 minus x. Go ahead. Take the pass on your way up. Left over here, we've got a 4. We have a negative x squared. am I done? Yeah, that 4 minus x squared. There's a couple ways that we could do this. I'm going to show you 2 ways. One way would be to go ahead and just straight up do difference of squares right now as it is. Difference of squares doesn't care where the variable is. Do you have a question? I think you might be like, are you just concerned with the way it's written? So I'm glad you brought that up. If you look at the other examples, that we don't end up putting a squared on it because we had 2 3 minus x's. Yes, one here and one here. But the idea is that each of them, they're not multiplied by each other. They're each multiplied by something else. So it's 3 minus x times 4, 3 minus x times negative x squared. When I write 3 minus x one time right here, multiplied by the 4 and negative x squared, I'm still saying it's x squared times 3x, 3 minus x, and 4 times 3 minus x. It still gets distributed to all of them. Does that make sense? Whereas the squared term would mean that I want to multiply it by itself, and I don't want that here. I'm glad you brought that up, though. Anyone have questions about that idea? Why there's just one 3 minus x? Devin, you doing okay over there? All right. So last bit here. This 4 minus x squared. I can just go straight to 2 minus x times 2 plus x. Does that make sense? It's kind of backwards from what we're used to, but it would work. That still is factored correctly. What if I didn't like that, though? What if I wanted that to be x squared minus 4? Do we have a way of switching the signs? Yeah, taking that negative out would let us switch the signs and switch their order. So let's do that. Instead of it being like this, which would have been fine, that would have been fine, but let's put it the way we're used to seeing it. Let's take that negative and put it out in front of everything and make this x squared minus 4 instead. The 3 minus x stays exactly like it was. Now I have the x squared minus 4 that factors just like normal. X minus 2, x plus 2, negative 3 minus x. That is a perfectly acceptable answer. There is a nicer way to write it, though. Just like I took the negative out, I am free to put that negative back in. And so take a look at the purple one, 3 minus x. Wouldn't it be nice if it was x minus 3? Does that make sense to everybody? I can take that negative and distribute it back in. Or it means the same thing. You could factor out another negative from that set, and the 2 negatives would cancel out on the outside. Either way, I'm just going to distribute this in 3, negative 3, positive x. So x minus 3. Switching the sign, switching the order. And the others would stay the same. X minus 2, x plus 2. Sometimes it works out as nicely as that. That looks exactly like what we're used to seeing. Does that make sense? This one would have been fine also. They're equivalent. They're both equally right. Does that make sense to everybody? And if you're finding things like end behavior, y-intercept, they'll all work out exactly the same. Doesn't matter which one you use. Are we okay? I want you guys to do 10 minutes of homework here, 5-10 minutes. Specifically, start with the front page, odds. And I'm going to have you guys do, here's the ones I want you to do first. And Victor, I'll be right there. I see your hands. I want you all to do numbers 3, 9, and 11 first. So we're doing the odds, 1 through 19 odds. Don't worry about the back page yet. Start with 3, 9, and 11. If you get those done, there are definitely people in here that are going to knock out the whole front page in the next like 10 minutes. Okay, so there are recordings already up on the website. Okay, so I want you to watch this. And then you hear the advantage that you missed that. Oh. So I'll double check. You're just missing this. Start watching the video. So there's 4 on the they're all already up on our website. And then they'll list what today's last. And then the last part is going to kind of tie it. And then yeah. So for number 3, did everybody manage to take out the x squared or the x minus 7? Did that make sense, everybody? X minus 7, they share. What was in the second set of parentheses then? You just shout it out. X squared minus 4. Not much shouting. That's okay though. You got the right answers. Those of you who said it was right. Is everybody else good? I was walking around, saw a lot of you with this. Any questions on that step? Does that factor more? Yes. Right? Difference of squares. That's going to be x plus 2 and x minus 2. X minus 7 right there. Number 3 from the homework is done. Doesn't matter what order it's in, as long as you have those 3 factors. Number 9, I know some of you don't appreciate it when it's all letters, but we want to be able to do this as well, and it works the same way. We're still looking for what the first 2 terms have in common. So what could we factor out of the first 2 terms? C. So we've got C, and then what was left inside the parentheses? A plus B. Yeah, that was a C, a little funny C. So C times A plus B. What about from the next 2? Factor out D. Left over, A plus B. And again, if we did it right, those should match. Or again, not necessarily if we did it right, if this is going to work by factoring by grouping. Those 2 match, A plus B. And we're left with just the C plus D in their own set of parentheses. Last one, number 11. What do we take out of the first 2 terms? What do they have in common? 2x squared. Again, some of you saw the 2, the x, we need all of it. 2x squared, x minus 5. Second set, what are we taking out of those? 2, and I would take out the negative 2. If you don't take it out now, you're going to have to take it out eventually. So negative 2, leaving us with x minus 5. That way they match. Take the x minus 5s out. X minus 5, leaving us with 2x squared minus 2. Am I done? What else can we factor out? 2 right there. Let's take those 2's out. So right here, 2 comes out in front of everything. Times x minus 5 times, let's see, what color have I not used yet? Let's go with green. Hopefully you can still read it. x squared minus 1. Does that make sense to everybody that I need to put that minus 1 in there to hold the place of the 2 that I took out? It needs to have somewhere to go back to, some number to multiply back into. Everybody in the back, can you read the x squared minus 1, despite it being a very strange fluorescent green?
Why'd you put that color?
Because I'd used all the other ones, and only like a third of the colors are not neon. That does not show up well. So I try to stick with the regular ones, but we used most of them. You're right, the pink might work a little better. Now, am I done now? The x squared minus 1 is another difference of squares. I've run out of room though, so I'm just going to erase it. Everybody, that x squared minus 1, I'm going to erase it and put in its place x plus 1, x minus 1. That's our fully factored form. Does that make sense to everybody? The last example I need to show you is how do we take this and apply it to graphing like we've done before. We're just going to take what we did today and merge it with what we did last week. Okay, nothing new from now on. So everybody back to the notes and let's look at number 9. Look at number 9. Number 9, x cubed plus 2x squared minus 9x minus 18. I'm going to knock this out pretty quickly. This is in the notes, number 9. X cubed plus 2x squared. I'm going to take an x squared out of those, leaving me with an x plus 2. Negative 9x minus 18. I'm going to take a negative 9 out of those. X plus 2 again. Take the x plus 2's out. X plus 2, x plus 2. Left with x squared minus 9. X squared minus 9. That's a difference of squares. Factor that one. X minus 3. X plus 3. X plus 2 is still out in front. It is now factored and looking exactly like what we graphed before. So we can do this now, find the x-intercepts. Oh, you just need to talk to them for a moment? Yeah. Okay. Jackson, they want to talk to you real fast. What did you do this one? Your book. Yeah. So, are we all good? X-intercepts, focus. X-intercepts, -2, +3, -3. Are we good with that? X-intercepts. The opposite of each one, what would make each one 0? Y-intercept. Though that did not work. Y-intercept would be putting in 0. So 0 plus 2, 0 minus 3, 0 plus 3, 2 times -3 times 3 is going to be -18. And you could have gotten that from the original one too, right? Right there. If I put 0 in, I get -18 out as my y-intercept. And then the last piece here, this x cubed, the x cubed, odd and positive, I'm expecting low, high, and behavior. So when I graph this, x-intercepts -2, 3, and -3. -2, 3, -3. Y-intercept of -18. And low, high, and behavior. Start low, up, down, up. There's my graph. So again, the graphing is exactly like what we did before. It's just now we can factor stuff that we couldn't factor before. Yes. So number 11. If you guys want, you can start on the homework. You've seen everything you need. The homework is 1 through 19 odd. There was a request for number 11, so I'm going to do that one super fast. So I'm looking at this one. You can ignore me if you guys are good, or you can watch this one. I can take an x out of all of this. X times x squared, sorry, x cubed, plus 2x squared minus 16x minus 32. Then I'd look at the first two terms right here. X squared comes out of both of those. So x squared times x plus 2. Right here, I take a negative 16 out. Negative 16 times x plus 2. And then I still have that x hanging out on the outside. Right there. X plus 2's factor out. X plus 2, x plus 2. I'd have the x squared minus 16 in there still, which is once again a difference of squares. X plus 4, x minus 4, x plus 2, and x. That's factored all the way out. X-intercepts would be 0, negative 2, negative 4, and positive 4. So 0, negative 2, negative 4, and positive 4. Y-intercept is 0. We've already got that one. And then end behavior would have been positive even, so high, high. So I start up here, down, up, down, up. And that would be my graph. Did that make sense? All right, guys. Thanks for hanging in there. Hopefully you got most of the front page done already. And you just have maybe those 3 problems on the back page to do, 2 or 3 problems. Remember, the homework is 1 through 19 odd. 1 through 19 odd.